Hello, my name's Bill Malik. I'm with Trend Micro, and I'm here today to speak with you about the Zero Trust Challenge for hybrid cloud. Now, what is this going to involve? In the course of this talk, we're going to ask a little bit about what Zero Trust is. A lot of definitions out there, and I want to level the playing field. Then we're going to look particularly at what hybrid cloud lacks that Zero Trust can help with. This really will explain the core of this presentation. But in order to balance this, there are no panaceas, there are no silver bullets. We're going to ask some things about what Zero Trust cannot do and what hybrid cloud does not need from it. So that'll balance things out. In order to expand our horizons a bit, I'm going to delve into some future problems for hybrid cloud in edge computing and 5G in particular that are going to cause us to have to extend our understanding of information security architectures. And then we'll finish up with a couple of slides of recommendations and next steps. As for me, I've been in IT for 5 years. I started work as a programmer in Boston, wrote code in COBOL. Yes, I did the Y2K problem like many others. Went to IBM in Poughkeepsie, wrote code for operating systems, joined Gartner, was there for 11 years, managed the information security service, and also the application integration and middleware service. In the turn of the century, I became a member of a consulting organization, then was CTO of Waveset. And after leaving that following Sun's acquisition, I spent most of the time as an independent consultant, and I joined Trend about 3.5 years ago. So that's me, that's our task, and let's step in. What is Zero Trust? In order to understand the management of an environment this complex, I'd like to start with a story. This is about two people who are excellent watchmakers. They both make beautiful watches, and each watch has 1,000 parts. Now, Tempus, the watchmaker, assembles the 1,000-part watch one piece at a time. Hora breaks down the task. He builds a watch when he has 10 assemblies. An assembly consists of 10 sub-assemblies, and each sub-assembly has 10 parts. So they put together their watches, but when they're interrupted, they have to put the watch down, and whatever they're working on falls apart. So on the average, Tempus gets 500 pieces done before he puts it down and it falls apart. On the average, Hora gets 5 pieces done when he puts down the thing he's working on and it falls apart. They both create the same watch with the same number of parts. They both have the same skill. The difference is because Hora uses a methodology, because he compartmentalizes the tasks, because he understands the relationships of the components. Hora makes 4,000 watches for every watch that Tempus completes. This is a paper on the architecture of complexity that was published many, many years ago. I have the reference in the deck. Bear this in mind as we go through what's necessary to secure a cloud. If you get interrupted, we don't want you to lose more than a handful of parts. We certainly don't want to have to start over from the beginning. So what is it with cloud that requires all this additional care and feeding? Well, first thing is, there's always going to be something that you remain responsible for in cloud. Even if you're using a business process as a service, you're still going to be responsible for making sure that the service level agreement is being fulfilled, that you're paying for what you're asking for. Of course, the more you put in, the more you control. But at no point does it completely go away. And we're going to remind ourselves of that as we move forward. Notice the cloud does take some responsibilities off your desk, but not all of them. So let's begin by looking at what Zero Trust is. Zero Trust dates from actually the late 1990s, when it was known as the concept of network access control. The philosophy behind Zero Trust is there is no perimeter. There is no boundary of trust. There is no reasonable assumption that people who are inside that mythical boundary are somehow trustworthy and therefore don't need to be authenticated. In a Zero Trust world, there are no perimeters, and the cloud has no perimeter. There is a source of trust, and this is problematic. It's why the name is kind of difficult for me when I initially ran into it. There is one source of trust, And you go to that source of trust to authenticate yourself and to get the appropriate permissions. So let's say minimal trust, maybe a better name. You assume a minimal need to know. You will need multi-factor authentication to provide security in critical tasks, such as super users, such as permissions that involve control over devices that themselves have critical security functions. Uh, Zero Trust includes the actions of logging and verifying and auditing and reviewing those logs, making sure that what is going on is what you expect to go on and other processes don't happen. And one of the principles of Zero Trust very much is to establish and maintain a separation of duties. We don't want to have a single individual responsible for too many components. This involves some changes to our traditional mindset about information security. Traditionally, if you were on the private, corporate, internal network, it was assumed that everything there was trustworthy. In the Zero Trust philosophy, nothing is trusted by default. We assume that the identities are who they say they are. In the Zero Trust world, we verify everything. In fact, in network access control, if you attempt to link to a network, the system, the network, before admitting you, will scan your device to see if you've got current patches, you've run an antivirus scan, your antivirus scan is relatively current and correct and from an approved vendor and so on and so forth. We assume that users act responsibly in the traditional security model, and we grouse about the fact that the user didn't follow policy or our awareness and training program isn't working. Well, maybe a better approach would be to say users are busy and they have other things to do. So while they're going to do their best with security, it's not what they're being evaluated on professionally. It's a component. And so therefore, we're going to nudge them towards not making mistakes. And finally, in the traditional security model, we try to detect security attack behavior. We look for indications of compromise. Well, in the Zero Trust philosophy, we're going to make it harder for the attacker to do anything. Rather than looking for a particular indication of compromise, we're going to put everything in its own segment to the extent that that's feasible. So how do we get there? Well, in order to verify identity, we're going to rely on multi-factor authentication. In order to restrict network access, we're going to segment, we're going to use DMZs. We're going to be parsimonious about what resources are available to users on what networks. And we're going to use application safe listing to prevent updates, to prevent the installation of rogue code, to close down the attractiveness or availability of shadow IT or shadow cloud or even shadow OT. Now, this relates to SASE as a component of Zero Trust. One of the keys of SASE, Secure Access Service Edge, it's a concept that says you're going to put security controls in the cloud since that's where most of what happens goes on. One of the concepts there is to use a CASB, Cloud Access Security Broker, and a secure web gateway to make sure you know what applications are being accessed. And going beyond the traditional VPN, we want to have application-specific connections. A lot's been written about why VPNs are not the greatest, why they don't really solve as many problems as they pretend to. I won't go through those arguments now, but it certainly is a topic that we should discuss at some other time. Anyway, so this together brings Zero Trust, and I've introduced the concept of SASE, and we'll get later into edge computing, seeing how all this comes together as the next big things roll out, one of which, of course, is 5G. So why does hybrid cloud need Zero Trust? That's our next topic. And the answer is because there are a lot of security issues with cloud. New sets of services coming out all the time. DevSecOps, the sec is often silent in polite conversation, increases the speed with which new apps show up in the environment. These new capabilities provide new routes of attack for the bad guys. I'm trying to stay away from the word hacker. Back in the old days, a hacker was somebody who was very good at solving hard problems with computers. The notion that a hacker would do so for profit or would do so to cause trouble, and that's a relatively late innovation. So I'm going to be a little bit of a curmudgeon and say the cyber crooks are the ones we're worried about. There are many teams making acquisitions in infrastructure. They're making decisions about security policy, sometimes not even making them explicitly, making them by default. Experience has shown that the default security posture is inadequate, hence the need for a zero trust environment. Compliance requirements are increasing. There are legal and regulatory issues that organizations face. These will get stronger. We're beginning to see these enter even in the world of OT. And finally, there are far too many security tools. And this is a problem for a lot of folks. I'm going to deviate from the agenda just a moment here. Most organizations use about 30% of the capabilities of the information security tools they have installed today. And the reason is not because they missed something. The reason is because when they bought the tool, it was fit for purpose. And in the intervening months and years since they installed the tool, the vendor has continued to add capabilities. So there are a lot of functions in the security products you've already installed that you probably haven't turned on, may not have explored, and in some cases, tragically, may have actually bought alternative products to provide a function that you've already bought, paid for, and trained your users on. So a lot of challenges for cloud security. It's getting more complex. And this generates a lot of different pain points. Here are some of the ones that a person managing cloud will have to worry about. Audit and governance. Where's the data going? Who's operating on it? If I'm using a SaaS-based service, are there any residency requirements about that? There was an issue some years ago where an organization was handling financial data and they had subbed it out to a SaaS provider, and the SaaS provider had subbed that out to a team working in a country that was not on the approved list for the handling of that kind of financial information. Well, guess who the problem ends up on? You're not going to go to the subcontractor and say, you should have refused that work. And you're not going to go to the subcontractor and said, didn't you know that this data was supposed to stay in this geography? No, you're going to have to look in a mirror and said, I didn't make it clear enough. DevSecOps challenges the traditional notion of change and release management. I'm a big fan of ITIL. I'm a big fan of COBIT, by the way, also. But change and release is really the gate by which you get stuff from the world of development and test and experimentation into the world of production. And although we've certainly accelerated it, I surely hope that you have not taken away any of those controls. The controls still need to be in place. We still need to know what's going out there. We still need to be able to go back to a point in time and say, what set of application functionality and what set of data was available at a point in time? How can we recreate the environment that led to this transaction leading to that result? Interesting problem, especially when the data is not here and the processes are not here, and all we've got is some kind of an audit or transaction log. The pain points for information security include shadow cloud, include zero trust, which is related to identity management. The two are not synonymous. The definition of a CASB includes the notion of identity management. The problem with that definition is that identity management is one of those things that we, in the high-tech world of information security, call hard. Identity management is a tough problem, and you don't want to bundle a piece of it in with one other function. You'd rather have the CASB-like capability interface with a more general identity management solution that the enterprise can run one of globally. Garbage collection is an interesting problem. It has real implications for 5G, and I'll get to that later on. There are pain points associated with procurement and contract admin. How do you know you're getting what you paid for? How do you know you're not paying too much? How do you know that the acquisition conformed to your baselines for security, for management, for collection of performance data? I mean, did we really need that bump? Was the transaction level so high that we had to instantiate another 20 images at that point in time? And how long did it take to clear it up? And when people buy cloud on their own, are they conforming to our procurement guidelines? Well, if they don't know what they are, the answer is probably not. And if they do know what they are, one of the reasons they went to Shadow Cloud was probably because they didn't want to go through all that stuff, just like with Shadow IT. Performance, capacity management, monitoring, those issues are generally harder with cloud simply because you can't put your performance monitoring tools into Google's or Azure's or IBM Cloud's data center and have them install them on the servers where your stuff happens to be running at the moment. And then there are skill and organizational challenges. First one that comes to mind is, gee, we moved everything to cloud and saved a lot of money on servers and storage. Gee, I'm an employee and I'm kind of expensive. I mean, if I take my salary and double it, that's my fully burdened headcount cost for this organization. I wonder if they're thinking about saving money on people the same way they thought about saving money on servers. That is, am I likely to be replaced by an outsourced third party individual? And when an organization takes the step to go to cloud and to go through that and to declare it a success because they downsize their data center, the people who work in the data center rightly are going to be concerned, well, are they going to downsize us next? And where do those skills go? Many organizations have gone so far in cloud, they cannot come back anymore. They no longer have the skills to handle change and release management, performance and capacity management, the installation and maintenance of physical hardware. Now, who has responsibility for what? The people in the organization may have new duties, they may be rotated into other assignments. They now need to know what constitutes effective performance. Note that Zero Trust does not address most of these capabilities. And that's the split between where Zero Trust helps cloud and where it doesn't. There are some problems, in other words, Zero Trust doesn't solve. So why do you need additional security? Well, we've talked about the increased range of threats, the pace of attacks is going up, the scope of attacks is increasing, and there are the issues I mentioned with compliance. Payment card industry standards are still in place. HIPAA regulations there, GDPR is getting stronger and being enforced more rigorously, and internal audit and compliance management. Are we really spending the money we thought correctly? So where does Zero Trust work in cloud? Well, hybrid cloud needs Zero Trust for identity management in real time. I got to know who you are and I got to know what you're allowed to do right now. That depends on an identity management infrastructure. Quick bit of history. We have a few minutes. In the beginning, computers were used to manage money in business. That was the first use. GE calculated payroll in order to save on the costs of a line of clerks, rows and rows of clerks tabulating payroll and so on manually. Numbers are easy. They are dimensionless. They're simply a quantity. They don't age, okay? So the 50s and 60s were about digitization in the sense of handling bucks. The 70s and 80s, we began not just computing bucks, but we began computing stuff, things, parts, bill of materials, and its successor database, bill of materials, BOMP and DBOMP, which led to enterprise resource planning, which led to supply chain management. Now, the interesting thing when you're managing stuff, as opposed to when you're managing money, is that stuff ages, it wears out, it has a sell-by date, it has a serial number, it has a history, it has a maintenance requirement, it has an expiration date, maybe, and it has certain parameters that may require it to be tuned and updated at a certain time. So it varies over time, but because these are physical things, they vary with an exponential decay kind of a curve. They age at a certain known rate. In the 90s, we began looking at, are there ways we can actually manage the capabilities of a person? That got us into the issues of, can I solve single sign-on? Can I solve distributed administration? Those two things came together in identity management. The problem with people is people are nonlinear and they vary non-linearly over time. You have one job and then you go through some training and you go to another job. Well, your permissions don't change. When you go from one job to another, it's not like you quit and started. There are some tasks that you got to finish up before the permission is let go. There are some permissions you're going to keep across the transition. There are some new tasks that you're going to pick up immediately, other new tasks that you're not going to be able to start until you complete some kind of training or background check. And ultimately, there are some permissions that you have now that will stop the minute you lose that job. So identity management is a really complex problem. Things that are inconsistencies may not be inconsistent at all. And so managing identity is a really hard problem, and doing it across multiple platforms is incredibly complex task. That's why there are only a couple of vendors that can even do this anymore. rely on them. Network attacks, big problem for a hybrid cloud because who knows what networks are involved there. You have a limited set of controls from your end as the enterprise manager as to what's going on. And shadow cloud is a significant problem as well. That's where a user installs an application and maybe unbeknownst to them, they end up subscribing to cloud. You put your Apple Watch on, you bring it to work, and the next thing you know, you've got Apple Cloud capabilities on your work machine because your watch found its way through Bluetooth to some local access point. These are tough problems to solve. And Zero Trust makes it easier because along the way, people in systems are going to say, is this permission allowed? Is this access legitimate given that individual's requirements, business needs, and current set of authorizations? So what does Zero Trust not do? And what does hybrid cloud not need from it? Well, looking at the security challenge a different way, there's the visibility of what's going on in the cloud. There's the question, do I know the rates, the speeds and feeds of my portfolio of instances right now? Am I able to update them through compliance? Am I able to secure them as they come into existence? Do I have the ability to bring up yet another secure instance? And I'm going to mention this point again. Every cloud instance is perfectly secure when it's created. It is only by the intentional acts of the people working on that cloud instance that it is rendered insecure, that it is rendered visible to unintended persons, that it ends up on the internet with access to everyone. That is a huge problem. And unfortunately, Zero Trust in itself does not really address that. If you've said the service is universally accessible, then Zero Trust will diligently grant universal access. Now, we'd like to see products that can nudge and say, are you really sure you want this to be accessible by everybody? Are you really, really sure you want to be? Click here if yes, and the OK button is that big. I mean, that's the kind of human factors we'll need to get in to force people to think through what are we really doing? Because what a cloud builder is thinking about is not about how to secure it. They're trying to help organizations that are doing cloud native, bringing new stuff to the new world in these various exciting new forms, using DevSecOps to drive new workloads with minimal delay, going with serverless capabilities. There's a Kubernetes joke involving the Suez Canal that I'm not going to tell, but that's on the left side. That's cloud native applications. Cloud migration is the organization that's in the process of migrating from a traditional data center or a blended environment into a hybrid cloud norm, cloud first, if you will. It doesn't mean there won't be anything left. It just means we're going to be parsimonious, stately, and appropriate in our progression from this here data center into that there cloud. And then finally, on the right, the set of strategic priorities is, are we doing as well as we can do? I'm developing a talk to be delivered later this year that actually looks at what cloud operational excellence is. Back in the 90s, Gartner acquired a company called Real Decisions. They did benchmarking. The goal of Real Decisions was to help people figure out how efficiently they were using their data resource, their processing resource, their network resource. And what they found was, generally as a rule of thumb, the top 10% were an order of magnitude better at making use of those resources than the bottom 10%. Whether it was people or staff or organization, network hardware, software-defined networking, whether it was software-defined storage, whatever it was, the difference between good and bad is an order of magnitude, which means you need to know what you're good at. And if you want to use cloud, you don't have the option of backing out of it. You've got to figure out how to get better. So we need to look at that. Now, I'm going to dig in a little bit, some vulnerabilities. Shadow cloud, the problem there, tech's cheaper than ever. Just like shadow IT, shadow OT, individuals can purchase capabilities for very small amounts. stuff that doesn't even reach the threshold of a purchasing decision, stuff that shows up on an individual's credit card. I use a service to post-process my audio work when I do blogs. I pay $11.70 a month for that capability. If I had to install the software and train up on the product, it would be probably 2 months of training and hours of work on the machine. In multi-vendor environments, digital platforms with heterogeneous environments, this is the process of digital transformation. The fact that you're going to have shadow cloud hanging around there is a real risk. It can become a portal for attack. It can become a path for exfiltration of data. And the existence of these, whether they're integrated in a full digitally transformed enterprise or whether it's just some simple SaaS application with a new feature, you don't know. For sitting inside IT as these things happen, you do not know if you've been attacked, if somebody made a mistake, if it was simply a side effect. You do not know what's going on. Shadow Cloud really puts things in a pulse. So, the first reaction is, can we lock it down? Don't think about perimeters. Think about actions and user needs and what you can do to nudge them towards correct behavior. And here's the message. Misconfiguration is the biggest problem you've got. Every cloud instance starts out perfectly secure. It is converted into an insecure environment following the procedures that your technical team has well grooved. So here's a big pitch for process improvement. Here's a big pitch for first failure analysis. Here's a big pitch for process innovation to rectify, to correct those kinds of issues. So lastly, I want to get into some of the exciting new stuff that's happening. Edge computing, I jumped a slide. New stuff that's happening, edge computing, 5G, and how SASE, these are going to stress hybrid cloud. So what is going on with edge computing? Well, Moore's Law, we all know, the number of people who think Moore's Law is about 10 doubles every couple of years. It turns out in reality, there are 3 flavors of Moore's Law. Processor density at constant cost doubles about 18 to 24 months. Storage density doubles about every 12 to 15 months. Network capacity doubles at a 9 to 12 month frequency. In other words, there are 3 different flavors of Moore's Law. Let's take a look at the implication of these exponential growth curves. The area I've highlighted here on the bottom right at month 120 shows that after 10 years, processor capacity has gone up by about a factor of 10. Storage capacity at constant use has gone up. Processor 100. Storage capacity has gone up by a factor of 1,000, and network bandwidth is 10,000 times greater. That's been our experience for more than a decade. This means that you no longer want to have a large computer with resident data. That is an inefficient model. What you want to do instead is to move the data to the relevant processors. Here are the conclusions. Move the data to the relevant processors because large amounts of data can get there quickly. We've got the bandwidth. Latency is still a problem for real-time applications. So you want to have the processors close to the action, close to the devices that are being managed. Think self-driving cars, think V2V environments or V2E inside of crowded cities. You want to have lots of data globally available. You want to move that data to nearby processors. Those are edge machines. It may persist there, it may not. Note that, interestingly enough, edge computing partially solves the problem of the outer join. If you don't remember what the outer join problem is, go in peace. It was a tough thing basically from the day that SQL was invented. So what SASE does is it says, let's recognize the reality of the new environment. Securing the establishment inside solves less than half the problem. More people are doing work off enterprise than in enterprise. More workloads are running in various forms of infrastructure as a service than in the enterprise data center. More apps are consumed via SaaS. More data is located out the enterprise. More traffic for public cloud than the enterprise data center, and more traffic than from branches heading to the cloud. We are not a centralized organization. There's a vestigial data center at the enterprise headquarters, but everything is outside. So protecting the perimeter from an internal set of controls is going to miss most of the action. So we want to get from SASE to zero trust. SASE was defined in 2019. A lot of vendors have jumped on the bandwagon. A lot of people are more confused. That's why we went through the introduction. Secure Access Service Edge. Zero trust is you never trust. It's not focused on a particular tool. It's a philosophy. It's a design principle. SASE, on the other hand, is directly related to taking advantage of security based in the cloud. The SASE vendors themselves will identify themselves as SASE, and it must be deployed by a provider in the cloud. So SASE is a instantiation of zero trust. The common goal is to secure the business with context-sensitive and identity-based policy management. Zero trust does that generally as a design. SASE does that specifically as a particular information. You can compare vendors of SASE products. You cannot compare discussions of zero trust except on terms of intellectual completeness. One last task, I mentioned this, I want to get through this. It's a detailed problem, but it goes back a long way. John McCarthy in 1960 identified a problem called garbage collection. The programming language Lisp would operate by defining trees and then pruning trees for branches that were not needed. The problem, the garbage collection problem, was these pruned branches were not associated with a potential free space storage location. And therefore, they had to be dealt with asynchronously and offline. The problem was kind of solved, but all of us remember the days when certain machines had to be restarted after a few days or a week because things got jammed up. You didn't have available storage. Well, the garbage collection problem is going to be coming back in a big way with 5G. The reason is 5G is going to be creating new cloud images, new networks dynamically, new storage spaces dynamically, and new suites of applications dynamically for each user of a 5G phone, for each machine that is relying on a 5G set of services. And for those that move around, for a user walking through a city center, they will be jumping from one suite of cloud-based services to another suite. They will be crossing a boundary every few hundred yards. And that entire stack will have to be torn down and reinstantiated in the new environment. The problem isn't cleaning up the cloud remnants. We got that down. The problem is the metadata, the tables that tell you what's the number of the next instance, what's the total number of available slots to handle instances of a particular application. When those tables fill up, then things go haywire. We saw it 2 years ago when satellites rolled their counters. We saw it again in the last year and a half when certain aircraft have to be cold rebooted after about 140 hours of service. We saw it when certain printers started to fail because they had exhausted some counters. It wasn't because they had data hanging around. It's because the metadata didn't exist. And that problem is not going to go away. It's going to get significantly worse because of the presence of 5G driving the rapid creation and instantiation and takedown of all these new cloud environments. So, what have we learned today? First of all, define your processes and procedures, refine them, clarify them, audit them, and then automate them. Make sure you put the controls early in the development and integration lifecycle. Consider boosting the strength of your identity management program. Identity-centric security cannot be done on a domain-specific basis. It has to be universal. Take a look at the gap analysis for infrastructure and operations functions for governance. Ask senior leadership, who does this? They give you a name. Ask the IT organization, does so-and-so do this? Who does this? And then look at the gaps and say, what do I need to fix it? You got to know what software you're running, including stuff that's been rented, not just stuff you built yourself or stuff you purchased long-term. Make sure you align your procurement with the informal buying centers. Provide information, provide guidance, and upgrade your tool sets. See what your vendor capabilities are lying there that you haven't been aware were added to technology you bought 3, 4, or 5 years ago. Take a look at SASE as an evolutionary step forward, as a way to protect your enterprise as it becomes more cloud-based and less enterprise-centric. And take a look at zero trust network architecture. Get rid of the notion of a perimeter. Consider how you would pilot that, and consider bringing in somebody from the industrial control systems and OT sides, because they're still thinking that the perimeter will save them. Make sure you architect your solution one step at a time. I don't want you to put it down and fall apart and have to start over from scratch. Piecemeal doesn't work. Make sure you've got a solid plan. So I would like to share these references with you. The paper by McCarthy from 1960 is right there at the top. Documents on SASE and cloud are available. And now I'd be happy to take questions. Put them in the chat, and I will be answering them as we go.